Now we are going to find the volume by using triple integral. So in the previous video I said for area we will use double integral and for volume we will use triple integral, and the formula is volume is equal to triple integral dx, dy and dz. Now we have to fix the limit for x, y and z. So they have given find the volume of a tetrahedron bounded by the planes. They have given x0, y0, z0 and this. So this will be like a pyramid, the tetrahedron. So we have to fix the limit for this. So first they have given three planes as 0. So if you substitute z as 0, what you will get for this equation? X by a plus y by b plus z by c is equal to 1, right? So you will get x by a plus y by b is equal to 1. So which implies y is equal to 1 minus x by a into b. So this is your limit for y. Similarly, if z is equal to 0 and y is equal to 0, then what will happen to this equation? X by a is equal to 1 because the other two will become 0. So therefore x is equal to a. So now we are going to fix the limits for this triple integral. So v is equal to x is equal to 0 to a, y is equal to 0 to b into 1 minus x by a. From where we got it? From here. And then z is equal to 0 to, for this x is equal to a is here, okay. Z is equal to 0 to where it is? From the equation. If I put z is equal to 0, then if you from this equation if you take, what is z? Z by c is equal to 1 minus x by a minus y by b. Therefore z is equal to c into 1 minus x by a minus y by b. So now this is the limit for z. So z is equal to 0 to c into 1 minus x by a minus y by b. What is the limit here? Dz, because I have written z first and then y second dy and then finally dx. So first if I integrate dz, I will get z. So volume is nothing but x is equal to 0 to a, y is equal to 0 to b into 1 minus x by a into z. What is the limit for z? 0 to c into 1 minus x by a minus y by b. Only upper limit exists, lower limit is 0. So easily we will get v is equal to x is equal to 0 to a, y is equal to 0 to b into 1 minus x by a. If I apply the limit, c into 1 minus x by a minus y by b. The c is just a constant. So if you integrate 1 dy, you will get y. If you integrate x by a same as 1, that is also a constant. X by a dy, again I will get y minus 1 by b into, if I integrate y, I will get y square by 2. So same thing I have written, the c I have taken outside. So 1 if I integrate y, x by a if I integrate x by a into y, and y by b if I integrate y by 1 by b is a constant, y if I integrate y square by 2. So I am going to apply limit only for y and not for x. So I am going to apply limit for this y and this y square. So don't apply the limit for x. So what we will get? V is equal to c into integral x is equal to 0 to a. First if I apply upper limit, b into 1 minus x by a and then minus x by a into b into 1 minus x by a minus 1 by 2b into y square. So this is b square into 1 minus x by a the whole square. And then we have 1 tx, I must to write. So now 1b and this b will get cancelled. And let us simplify this first and then integrate with respect to a. So what I have to do to simplify? Just see here 1 minus x by a into b is common for all the terms. So I will write this x is equal to 0 to a. This b you can take it out. Okay. So 1 minus x by a if I take common, what I will get? Yes, this is what? This b is common in all the terms. So I have taken this b outside. And if you take 1 minus x by a common, so what is left over term here? Only 1 will be there. I have written this. and then only x minus x by a will be there. I have written it. This b has gone outside. Power 2, only one more term will be pending, and then this minus 1 by 2. If you see here, again, if I take 1 minus x by a, of course we have dx. If I take 1 minus x by a common again, already we have v is bc. We'll write this again. 1 minus x by a if I take common from these two terms, and see here, this is also 1 minus 1 by 2. So I will write 1 minus 1 by 2 dx. So what is 1 minus half? That is, leftover value is 1 by 2. So v is equal to bc by 2 integral x is equal to 0 to a 1 minus x by a the whole square dx. Now the whole problem reduced into a smaller value. So if you want, you can substitute 1 minus x by a as some t. 1 minus x by a as some t. So what is t square, integral of t square means minus dx is equal to, so you can substitute this also in terms of t. So minus dx is equal to a dt. What we will get? T square into minus a dt. Correct? So if I integrate, minus a into t cube by 3 you will get. So same thing I am going to write. V is equal to bc by 2 into minus a into, in the place of t, what does we have? 1 minus x by a the whole cube by 3. We are going to apply the limit only for x. X varies from 0 to a. So you will get minus abc by 6 into, when I apply the upper limit, 1 minus 1 by a, that you will get 0, minus when I apply the lower limit, this 1 by 3 we have taken outside. So you will get minus 1. So because 1 minus 0, and then finally we will get ABC by 6 cubic units because we are finding the volume. And also keep one thing in mind. If they have given find the volume by double integration, either you can use triple integration or volume double integration over the area. That also we can use. And one more formula is there. This is the one, volume of a solid obtained by revolution of a curve. So something is there. It's like if I revolute around this, then you will get an area. Enclosing an area A about the initial line. About the initial line means this is the initial line. I am rotating about the initial line. So now in polar form, this is a formula. Now if you see triple integral dx dy dz is also there, or double integral over the area A also will give you the volume. Double integral over area A, 2 pi r square sin theta dr d theta. This is the formula in polar form. So what are the formulas we have seen? For area, it is double integral dx dy in Cartesian over the given region R, and double integral over the given region R dr d theta in polar form. These are the two formulas for area. And for volume, what we have seen? Triple integral dx dy dz in Cartesian. So these two things we have done in the previous video. We have covered this, and I have given you the formula for the volume of a solid obtained by revolution of a curve in polar form is this. Thank you.